The graph below shows a transformation of y equals 2 raised to the power of x. So comparing the given graph to the graph of the basic function y equals 2 raised to the power of x shown here, notice how the given graph has a reflection across a horizontal axis as well as a shift up. Looking at the graph of y equals 2 raised to the power of x here, notice how the horizontal asymptote is the x-axis, which has an equation y equals 0. The given graph has a horizontal asymptote of y equals 2. So because the horizontal asymptote is y equals 2, we know the graph has been shifted up 2 units, and therefore d, the constant on the end, must be positive 2. And therefore the equation of the given graph must be in the form y equals a times 2 raised to the power of x plus 2. Again, we know the base b is 2 because the given graph is a transformation of y equals 2 raised to the power of x. Now to help us find a, let's find some convenient points on the graph. For example, this point here has coordinates 0, negative 1, and this point here has coordinates 1, negative 4. Using this point here, let's substitute 0 for x and negative 1 for y. So performing the substitution, we would have negative 1 equals a times 2 raised to the power of 0 plus 2. Simplifying, we have negative 1 equals 2 to the 0 is equal to 1. A times 1 is a, so we have a plus 2 on the right. Subtracting 2 on both sides, we have a equals negative 3. So this would give us the equation y equals, again, a is negative 3, so we have negative 3 times 2 raised to the power of x plus 2. Now to verify this is the correct equation, let's confirm this ordered pair would also satisfy the equation. So now we'll substitute 1 for x and negative 4 for y. So performing the substitution, we'd have negative 4 equals negative 3 times 2 raised to the power of 1 plus 2. So we have negative 4 equals 2 to the first is 2, so negative 3 times 2 is negative 6, and negative 6 plus 2 is negative 4, which verifies the equation of the transformed graph is y equals negative 3 times 2 raised to the power of x plus 2. I hope you found this helpful.